we're recording. Vertical line test. Okay, the vertical line test you guys may have seen before. The way the vertical line test works is that if you have a graph, let's say you got like a I don't know, something like this here. If you draw a bunch of vertical lines, the vertical lines can only touch once, or may not touch. But if it touches more than once, it's not a function. If it touches just once, it is. So that's what the vertical line test tells us, is that a relation is a function if no more than once. That's how you know if because then it would guarantee. Got a little hard to read. Sorry. Let me move that. May change the colors. There you go. Yeah, a relation is a function if a vertical line crosses the graph no more than once. Okay. So for every input, there's just one output. Now, an example of something that's not a function would be like this here. I know you guys seen circles in geometry. If I draw a vertical line, how many times does that touch? Twice, and that's not a function. Did you guys talk about equation circles in geometry? Did you guys do that at all? X squared plus y squared equals r squared? Oh, good, you did, okay. For example, that could be the equation of the circle down below. Because x, y are both squared, that's the reason why you're having two outputs, right? Because you have that squaring element that causes that to happen. That would not be a function. Another way to think about this too is that x can't be repeated. Because if it's repeated, it's not a function. So here, fortunate x is not repeated. X is unique. So the answer is yes. But look at this one. Does 15 lead to two outputs? It does, right? This is kind of weird, but when you have a mapping diagram, it's like saying -8, 7, -1, 9, 0, 9. So the y's could be repeated. That's okay. 15, 7, and 15, 9. I kind of have a sexist way of thinking of this. Don't be offended. So in some cultures, as you guys know, men can have many wives. What cultures? And you don't offend me. I'm Middle Eastern, so totally, but Muslims. How many wives do Muslims have? Apparently, you guys learn in the religion class. You guys know in the Quran what it says. I mean, I could have 4 wives. I don't believe that. I think it's crazy. Could have the 4 wives. I know it's kind of nuts. An actually funny joke. My wife and I we honeymooned in Morocco about 10 years ago, and in one of the bed and breakfast, they had like 4 like corners, and they joked that there's 4 corners or 4 rooms in each floor because the man would have each wife in each room. But anyway, I digress. Mormons have multiple wives, right? So this is my sexist analogy here. Think of X like the women and Y like the men. So she can't have 2 husbands, right? So that's not okay. So let's see, like 15 has 7 and 9, right? But 9 has like -1 and 0, so that's okay. I know it's weird. It makes no sense. That's my sexist way to think about it. Is that X can't be repeated, but Y can. I know it's weird. So if X were women and Y were men, so there's your sex way of thinking about it. All right. Just don't get me in trouble. All right. Don't. Okay. Number 3 is yes. So you see the Y is repeated. That's okay. The Y can be repeated. The X cannot. So that's yes. So this was no. That was yes. I mean, if you want to just keep it really simple, X can't be repeated, Y can be. There's no graph here, so I'll just make up a graph for you guys. So would that be yes or no? No, right? Because it crosses the vertical line, cross more than once. Or if you think about it, there are two points here that have the same x value. X is repeated for some of these points. Actually, for all the points except for the endpoints. So that's a no. All right. Now let's talk about evaluating. And you're going to cover all these functions in algebra 2. We're definitely going to talk about these three. We have actually talked about the first two. We'll talk about quadratic functions next week. We're not going to get to these two here. This summer here, this will be later in the year. You'll talk about this. I think probably late in the fall or early in the spring semester. But all this stuff means right here is a plugin for x. Plugin for x. So if I do that right now, I get negative 11. There I get 14. So let's just take a moment before I go too fast. All you're doing is you plug in a for x. That's all. That's it. Have you guys seen this before? Function notation. Does that make sense? Yeah, it's very simple. We do this a lot in algebra 2. Actually, this is what we'll just do more frequently because we have to kind of embrace this kind of notation because this is what you do in pre-calculus and calculus. So if you think about all the algebra 2 we're doing, we're giving it like a year of exposure to this kind of notation. So that when you move on to the next level, that you're just comfortable with this notation, right? So we plug -2 here, great. You get -11. Plug 1 here, great. You get 1 minus 5, -4. After that's 4, 3 times 4 is 12. 12 plus 2 is 14. Plugging -2 to this one. And it really is a lot of PEMDAS, really. I mean, that's what it is. That's -2 squared minus 2 times -2 plus 5. 4 plus 4, be careful with all the negatives. That's 13. All's good with that? We'll do the next two in just a sec. Let me switch to a different color, the red. Okay, here, plug in 0. So 0 plus 0 minus 0 minus 5, -5. Here, you get 1. So what does this really mean when you have function notation? So all this is called function notation. Why is this a good thing? So let's look at this here, right? You can say it one of two ways. You could say find what y equals in the equation y equals 3x minus 5 when x equals -2. Or you could say this. What's easier? White type in black or white type in light blue? Light blue is more concise, right? Mathematicians are lazy. We want efficient ways of expressing what we want. When you see this here, I know it seems cryptic. Like if you show someone has done math in a long time, but maybe if your parents are not, STEM, or like maybe say it. Like my brother's in real estate stuff, like he would not know what to do with this, right? But I know, like he math. But somebody who hasn't done math in a long time, they're like, huh? Like, what the heck is that? But if you spell it out, saying, hey, find what y equals in the equation y equals x minus one x, and someone knows, oh yeah, okay. I'm putting that, okay, great, work it out and get the answer right. But if we want to take all these words and express more concisely, that's why we have function notation. That's why it was invented. It's to be more efficient, because you're going to start doing more advanced stuff. We can't have all these words. We have to make it more tight and neat. So that's why we have it, just so you know. All right. Okay. So now let's talk about this here. Now we're going to start getting into more graphing stuff and linear functions. And we're going to talk about intercepts. I'll do A and B. I'll have you guys do C, D, E, F. So how to find an x-intercept, pretty simple. I said this in the video. Or let me write like this. Geez. Substitute 0 for y. There you go. That's it. How to find y-intercept? Substitute 0 for x. Right? Very simple. Okay, once you guys try C, D, E, F, I'll give you guys about a couple minutes to do that. I'll do it too, and we'll see if it's the same thing. Seeing here a little funny, so if you're stuck, let me know. All right. Here we go. I said C here a little funny. So C is a fraction, right? And you're asked to find x-intercept. You're plugging 0 for y, not 0 for x, right? You're trying to solve for x. Now, here's the thing with fractions. And again, I said this, I think, maybe a couple days ago. Like, I think COVID really kind of set us back a little bit, right? I mean, well, I'm hoping we stop talking about COVID after a while. But still, the reality is that 3 or 4 years ago, we was in middle school, fractions are supposed to be reinforced, and whatever happened online, I don't know. Maybe things get fell by the wayside, but when you have a fraction, if the fraction equals 0, what has to be true? The top has to be 0. I don't care about the bottom, because 0 divided by any number is always going to be 0. So when the fraction equals 0, the top is 0. That's it.
X equals 0, X equals -1. Who cares about 1? Now I know the bottom can't be 0, that's another scenario, that's undefined. So what is undefined? The 5. 5 we can't plug in. But it's really about what's the top, like 0 over anything is 0. Now this is fact we're going to talk about next week. This is right back for you. So something times something. So that's what this represents. X plus 1 is one entity. 3x minus 6 is another entity. These two entities multiplied together equals y. But if I replace y with 0, that means that one of these two things has to be 0. Why? Because what's a number times 0 always going to be? 0. So either this is 0 or that's 0. Sometimes both could be if they're identical, but the bottom line is that one of those two things has to be 0 for this to work. So either this has to equal 0 or this has to equal 0. So I deliberately set each factor. These are factors. I deliberately set each factor equal 0 and solve for x. -1, 2, done.
D and F are more straightforward. Just plug in 0 and work it out. That's PEMDAS, right? You get 5 for D and -6 for F. C and E just had to be a little more mindful about your algebra. So cool. Yep, right. I'll just wait a while some of you guys are still jotting stuff down. All right, cool. I'll just wait a little bit. Now let's talk about this stuff. What is a linear function? There's a few ways you could define. I think I put in the video. Essentially, it's relationship where x and y both change in a proportional actually, is that right? Say that. Hold on. Give me a sec here. Don't let me think about this. Okay, here we go. I got where the change in x and the change in y happen in a proportional manner. Trying to channel my inner grammar and English skills here. All right. That's what it is. At its core, that's really what it is. Yes, is it a line? Sure. But why is it a line? Because of this. At its core, that's really what's happening. Because if you think about it, you guys have seen this before, right? Y equals mx plus b, where m is the slope. B is the y-intercept. And what is slope? The change in y over the change in x. Or so I'll do this on the board. So you don't have to write sense, just kind of just pay attention. 1, 2, 3, 4, 7, 10, 13, 16. Yeah. How's that changing, guys? When what's happening? That's changing by what? Goes up by what? 1. Every single time goes up by 1, right? Plus 1. Plus 1. Plus 1. Here, plus 3 every time, right? So is the change in y, which is 3, the change in x, which is 1, does it happen in a proportional way? Yes. Because every single time it's 3 to 1, right? If I tell you look at these 2 points, look at the change, that is 3 to 1, right? If I do 10 minus 7 or 2 minus 1, that's 3 to 1. What if I took the first point and last points? Right? 16 minus 7 or 4 minus 1, that's 9 to 3.
What's that reduced to? 3-1. That's what proportion is, right? In case you guys forgot the word proportion. Proportion is a ratio of equal values, right?
Actually, write that up here. The proportion two ratios, which are fractions of equal value. Okay.
So that's what's happening here. So the change and exchange are always happening in the same proportion. So if you plot this, then guess what happens? If I plot this, I'm gonna try this as neatly as I can. I'll do my best. 1, 2, 3, 4, 5, 6, 7, 8. Crap. This device, this is gonna be crap. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. See, all those dots fall in a nice line, right? That's why it's called linear. It happens that way.
So that's all that happens is that if you take any 2 points, find the slope, that change y or change x is going to be consistent every single time. When that happens, you got a line. If it doesn't happen, it's something else. And that's m. M is the same thing as slope. Now b is a y-intercept. That's a nice form to have because if you know where it crosses the y-axis, and you can identify one point of the graph, right? Because y-intercept is when you touch the y-axis, and then you can use a slope to get a second point. We'll talk about graphing lines in a little bit. Like for example, you have y equals 2x plus 3. Like if I plug in 0 for x, what does y equal? 3, right? So you plot 0, 3. And then the slope is 2. So if I go up 2 and right 1, I get a second point, right? Because up 2, right 1, right? Change of y is 2. The rise over run, right? We think it was rise over run. That's another way of thinking about 2. That's hard to read. Sorry about that. But 2 is 2 over 1. So if you change y by 2 and change x by positive 1, that gets your next point. And now you got your line. So that's the beauty about slope-intercept form. You can easily graph when you have that information. And you can easily visualize that linear relationship. Going back to this example again. By the way, this is not linear. This is called a multi-linear, I think. I should know this. That's a weird equation, so don't worry about that one. That's more advanced. I'd use the code for that one. But like this one here again, right? Y equals 22,000 plus 0.04x, right? That's a linear equation. So like, let's say my brother's a real estate broker. He is, but assuming this is his salary, if he doesn't sell anything, just sits on his butt, or he makes all these phone calls, no one wants to buy from him, then he gets $20,000. But let's say he sells $1 million, has $1 million in sales, right? That would be what, 40 grand? So he makes $62,000, right? And let's say he sells $2 million worth of homes. I think that's an extra 80 grand. So that would be $102,000. That's linear, right? His salary is linear, right? Because the more he sells, it changes in a linear fashion. In fact, actually, that 0.04 means that for every it's 0.04 over 1. And think about what this means, right? X, I'm getting kind of the deep end here, guys, but it's good to talk about. Delta X is a change in home sales price, or it's change in home sales. 0.04, that's a change in Y, is a change in salary. What this means that for every dollar, because 0.04 is 0.04 over 1, for every dollar of a house he sells, he makes 4 cents. Of course, you're not gonna buy a house for $1. You can buy a house for $1 million or $2 million, right? But that's what that represents. For every time the home sale goes up by an extra dollar, like say for example, he sells a house for $1 million, right? But if he sold so he gets $40,000, right? If you do 0.04 over a million, but what if he sells out for $1,001? Then he gets $40,000 and 4 cents. Because every time that the home sale goes up by $1, his salary goes up by 4 cents. So that's how you got to think of slope. You got to think of like that. Context. Now, point slope form. Oh, that's hard to read. Let me rewrite like this. So it's very similar to the slope intercept, which is this. But x1, y1 will be a point on the line. Okay, so point on the line. And M still your slope, right? This actually, just so you know, is actually the preferred. Is the preferred form. As you guys move on to, because some of you guys, some of you guys are rising sophomores, right? So you'll probably do calculus in school. If you're a rising junior or senior, you'll do calculus in college, right? And but even then, whenever you do calculus, this is what we prefer in calculus classes because it's an easier form to work with. Because if you're given a point and you know the slope, then you just kind of write. You don't have to rearrange things. So sometimes you rearrange stuff, you can make mistakes. So this is kind of the preferred way to write it, just so you know, we'll get in a habit of that. I've taught calculus many times, and if I can get you in a habit of that, that's a good thing. So let's graph. Actually, getting close to break time. Let's take a break right now. Let's come back at 10:10. We'll finish this off, and those do some prompts after that. Well, my computer's acting really slow, so give me a sec here. Okay. Okay, guys, let's get started. So what you have to recognize here, guys, quiet, please, thanks. That's point slope form. Thank you. All right. So that's point slope form. And so is this one as well. Well, kind of. Not really. We'll come back to number 2 in a sec. That's point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. So it's important that you recognize the form that the line is in. So what's your slope for this one? What's m here? Exactly. Thank you, Michelle. That's great. And then the point, that's a little tricky. The reason I say it's tricky because you have to be mindful of the signs. That's x plus 4. That's x minus x1. So what do you put in place of x1 to get to be a positive 4? Well, what x1 have to equal to make that a plus 4? And this formula is here. -4, exactly. Thank you. It's gonna be -4, right? I know it's weird because you see a plus 4, but it's actually a -4. And that y minus 2 is actually a 2. So your x1 is actually -4, and your y1 is actually 2. Even though you do see a positive 4 and -2 in the equation, you gotta do the opposite. Just the way it's written. That's something we'll talk more about when we talk about transformations. The more I think about it, I think we should talk about transformations. Maybe tomorrow might be a good day to do that. Because it is such an important part of algebra 2. But anyway, just make sure you apply the formula correctly. So you're going to plot -4, 2, which is right here. I think I did that right. 1, 2, 3, 4, right? And the slope is 2/3. So that means you go up 2, right 3. Right? Because +2 and +3. So we'll go up 2. Let's change colors for a bit of contrast. Up 2. 1, 2, 3. Right 3. And there you go. That's it. That's all you do. Now for 2, it's not necessarily in point slope form, but what I could do is I could rearrange it like this. Negative 5x minus 5 minus 4. Right, distribute it, and I get negative 5x minus 9. So now this is in slope intercept form. I could have done the same thing for number 1, by the way. If you want to put in slope intercept form, totally could do that. What's M here? What's B? Oh, it's not. It's a negative 9. After we distribute it in combined like terms. So yes, you do see a negative 4, but you have to distribute first because it's not quite in that form in the beginning, but I forced the issue. And oh boy, I need to extend this. So see 1, 2, 3, 4, 5, 6, 7, 8, 9. And slope of negative 5. That's also kind of tricky too. All right, so you got this. So negative 5 means down 5, right 1. Because remember, any whole number or integer could be a fraction. Just put 1 in below. So, or you could do this. You can go up 5 and left 1. That's still negative 5, right? So we'll go up 5, 1, 2, 3, 4, 5, and left 1. There's my next point. And I just connect it. Okay, that. Steady hands here. Okay. There's your line right there. So, a couple ways you do it. If it's in point slope form, just an answer at a point, you just slope at the second point. If it's in some funky form or slope intercept form, where you want to force the issue of slope intercept form, force the issue to get the slope of y-intercept. Y-intercept a point, right? 0, negative 9, right? 0 for x, y is negative 9. And then use slope to get the second point. Or I could have gone down 5 and right 1 if I extended the graph or the coordinate plane. It's up to you. So you have lots of different ways you could do it. Can you make a random table? Sure. You can make a random table, plug random values of x, but that's more work. Then you're doing more computation. And that's when careless errors happen, right? So we want to avoid careless mistakes if we can. Some more I think about, I just want to do 3 and 4 and then end the notes there. And we'll do the rest of the notes for chapter 2 tomorrow. So here, graph using x, y intercepts. Okay, x equals 0. We'll solve for y. And y equals 0. Let's solve for x. And likewise here. X equals 0. Solve for y. Y equals 0. Solve for x. At this point, we can just do it mentally. I don't think we have to be too drawn out here. Like if I plug in 0 for x, it's why I need for x. If that goes away, negative 6, right? And if I plug in 0 for y was x equal 4. So y equals negative 6 or 4. Sorry, y equals negative 6 or x equals 4. So 0, negative 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So you have a point right here. Point right here. I'm gonna be a little smarter about this. Oh, look at that, so much nicer. There we go. Right? So you totally could do that. That's totally fine. I didn't do that for the other 2 problems because that would have been a little more work, I think. But when it's written like this, and by the way, this is called, I haven't talked about this form yet, but I should. AX plus BY equals C. That's called standard form. Standard form is very popular when you're making word problems with this. Like we're going to talk about word problems on Monday, where 2 equations, 2 variables. Like say for example, we saw this already. I think should I close the chapter 1 notes? Shoot, what? I can't remember off the top of my head, but say for example, you got 2 unknowns. Like say you're looking at like you're going to say, for example, we have like a theatrical performance at the Campbell Center, right? And let's say student tickets are $5, adult tickets are $10. And so you have 50 people in attendance and you collect $1,000. How many students and adults attended, right? So you can set up the equations kind of like using this. So for example, I just totally just made this up, like $5 for a child ticket. You don't have to write this down. $10 for an adult ticket, right? And let's say X is children, Y is adults, and say there's 50 people. And you collect, let's say you collect like $200. So it'd be X plus Y equals 50. And 5X, that's the 200 there. And 5X plus 10Y equals 200. That's standard form. Standard form is great for that, just so you know. So we'll talk about that with word problems. And if you're trying to graph them, using X and Y intercepts probably is a little easier because you don't have to get X, Y by itself. Or Y by itself to, again, slope intercept form. So anyway, let's find the intercepts here. If I put in 0 for X, Y should be 2. Plug in 0 for Y, X should be 5. Yeah, there you go. So that's what we're gonna do. Okay, homework, which is a great time to do now. So you're gonna look at 1 through 6. Identify the domain and range. So remember, domain is just X. Range is Y. To tell what the relation is a function, X can't be repeated. Here, vertical line test. And then 7/8 graphing, 9/10 plugging in. That's pretty easy. And what I want you guys to work on, let me put on the board here. Definitely section 2.1, number 1 through 10 all. Section 2.2, section 2.3. Oh, and someone asked a question. You don't have to submit stuff to Schoology. I'm not like collecting, or don't worry about that. I mean, if you want to, you can, but it's not necessary. Hold on a sec. Section 2.2. We'll see number 1 through 4 all. Then 2.3. There we go. Okay, that should be plenty.
Yeah.
There we go.
I would ask you And my friend. Oh, and great. I mean, I wasn't. I don't want I only. I should have taken. That's what's fine. I'm like, I was probably like, yeah, we can switch it. Yeah, that was. Cause I've heard one thing. Oh, yes, so there's no number for the, you have the, There. I have. So sorry.